All right, so we're here on our next section, which is section 2.4, which deals with formulas. So on this table here, we have three types. We have a rectangle, an area of a triangle, and then an angle measure in a triangle. So to recall your memory, right, to find the area of a rectangle or square, you just multiply the length times width. Okay? To find the perimeter, you would add up all the sides. Well, if we have a rectangle, two sides, the opposite sides are going to be the same. So to find the perimeter, you just multiply two of the lengths plus two of the widths, and you'll get your perimeter. So remember, perimeter again just means the outside. You're adding up all the outside. Okay, area is the inside. And area of a triangle, if you think about it, if you take a square and cut it in half, right, to find the area of that half of that triangle, it would be half times base times height because you took a square and you cut it in half, okay, or diagonally, and you got a triangle. So that's where that formula comes from. The area equals half times base times height, okay? So that's how you find the area of a triangle. Now, in regards to the angle measurements of a triangle, okay, so all the angles of a triangle add up to 180 degrees, okay? So if we had 40 plus 60, that gives us 100. If we take away that from the 180 degrees, we have 80 degrees left over, okay? So all the angles of a triangle add up to 180 degrees, okay? So let's focus a little bit on that right now. So there are three types of triangle, correct? So you have just a triangle with, let's say, all the sides are the same. Okay, so this is an equilateral triangle. So that means all the sides are the same. All right, so that's what these little mark indicates, that the sides are the same. So if all the sides are the same, what do we know about the angles? Well, all the angles are also going to be the same, right? So all the angles are going to be the same. So in this case, if we know that so in this case, the sides are equal, okay, and the angles are equal, okay? So if all the angles are the same and we know that it adds up to 180, what do they have to be each? Which angle? What's the degree angle for each angle? 60, right? So all of this has to be 60 degrees, okay? All right, another type of triangle you have is a um, isosceles triangle. And I believe this is how you spell it. Okay, isosceles triangle. So isosceles triangle means two of the sides are the same. Okay, so two sides are equal. Okay, and so if two sides are equal, what do we know about the base angles, these angles here? Well, the base angles would have to be the same. Okay, so the base angles would be equal. Okay, so if this was, say, you know, 45 degrees, then this is also 45 degrees. Okay, so that's what it's saying. The base angles are the same. Okay, and then another type of triangle is it's called a scalene. I'm trying to draw one, but anyway, it's a scalene triangle. Okay, scalene means none of the sides are the same. Okay, and then none of the angles are the same as well. Okay, none of the angles are the same. Okay, So again, so again, I would say like this, right, indicating that there are three different sides, and then I would, mark this as one, two, right? One angle, two angles, three angles, indicating that um there are three different angles. Anyway, so we have three types of triangles. Okay. So let's look at this question here. It says, the measures all right, it says here, the measures of the angles in a triangle are 3x, 4x, and 11x. Okay. The measures of the angles in a triangle are 3x, 4x, and 11x. All right. We want to find we want to find the value of x. Okay. So again, the measures of the angles in a triangle are 3x, 4x, and 11x. Find the value of x. All right, so let's read it one more time. It says the measures of the angles in the triangle are 3x, 4x, and 11x. Find the value of x. So if we were to draw a triangle, again, this is not going to be drawn to scale. I'm just Okay, it's not drawn to scale. And they tell us that you know, um say this is 3x, this is 4x, and this is 11x. Again, it's not drawn to scale. Okay? So what do we know about the angles, or what do the angles add up to in a triangle? 180, right? We know it's 180 degrees. So if we just add these up and equal to 180, okay, that would be our setup. So we have 3x plus 4x plus 11x, right? And that equals to 180 degrees, okay? So, and then we just solve for x. So 3x plus 4x is 7x, and then plus 11x is going to give us 18x, right? Right? So 3x plus 4x plus 11x is equal to 18x. And then we just divide by 18, okay? And then x will give us 10 degrees. Or I should say 10. The value of x is 10. Right? And if they wanted to find the actual measures, then we would just plug it in our x for each and every of the angles. Okay? But they just want the value of x, so there it is. All right, so here we have four more types. We have a circle, a trapezoid, the volume and surface of a box, and then the volume of a cylinder. All right, so For the first one, the circle, right? To find the circumference, which is the basically the length of the circle around, is you use C equals 2 pi r. And they gave us an example here, how to do that. And for the area, which is inside the circle, that's just pi r square. Okay. Um, for the trapezoid, the formula for that is half times a plus b, or base 1 plus base 2 times the height. That's how I remember it. But anyway, so the top base and the bottom base, you add them together, all right, and then multiply by the height and then divide it by 2. And they show this that here. For the box, so to find the volume of the box, we just do length times width times height, okay? All right. And then to find the surface area, that means like outside the box, then we just use this formula here. Okay. If we know all the measurements, we just plug it in and then we get our value. Okay. And then for the volume of a cylinder, right? So like a soda can or something like that, inside the soda can, all right, you use the formula V is equal to pi r squared times h. Okay. So in this case, the radius is 5, the height is 20. You plug it into the formula and you get your um, the volume of this cylinder. Okay. All right. So I want to look at this problem here. So out here. Okay. Okay. So we wants us to find, this is like a composite area, basically putting different parts of geometric shapes together. Um, that's what a composite um, shape is. Okay. So here it says we want to find the area of the lot shown, which consists of a rectangle and two triangles. Okay. See if you can figure this one out. Okay, so let's look at this problem. I appreciate those who have submitted an answer. So we have this shape, okay? And again, a composite just means you're putting different shapes together to form a bigger shape. So I recommend breaking them into parts. All right. So for me, I see three shapes here. We have the small triangle, the big rectangle, and then the bigger triangle. So I recommend doing them in three parts, but it's up to you. All right. You might see a trapezoid here. You can use that if you want to, and then do the small triangle, or you can do the trapezoid on the left with the bigger triangle. Whatever works with your brain. But I'm going to do three parts just to be safe. Okay, so I'm going to label this one A1, this one will be A2, and then this one will be A3. Okay, A1, A2, and A3. Okay, so for A1, all right, we know that this is a triangle, right? So the area of this is 1/2 times the base times the height, correct? We know that's a triangle. So let's plug that in. So we get 1/2. The base is the 10 yards, right? So 10 yards. And then the height is 20. Okay. So we just put this in the calculator. Half of 10 is 5, and then 5 times 20 is 100. Okay. So for that first part, that A1 part, right? This area here, okay, that's gonna be 100.
How do we get 100?
So I did half of 10, right? 1/2 times 10 is 5. And then 5 times 20 will give us 100. Okay. All right. Now for A2, okay, that's just a good old rectangle, right? So that's length times width or base times height. Okay. So our base is 60 yards and then our height is 20. Okay. So we just put that in the calculator and that gives us 1200. Okay. All right. So this is, make sure we have our units here. This is square yards. This is square yards. Okay. And then the last part here is the other triangle, right? So 1/2 times the base times the height. So if we look at this here, we know what the base is, right? This is the base, right? So that will be what, 30? What's going to be our height? What's our height? Perfect, right? The height, exactly, right? The height is this here, isn't it? That's our height, right? So that's going to be 20, okay? All right. So times that by 20. All right, so we just do half of 30 is 15, isn't it? 30 divided by 2 is 15. So half of 30 is 15, and then multiply it by 20. That gives us 300. Okay. Then we just add them up. And then this is square yards. Okay, that's how you say it. Square yards. Okay. All right. So we just add them up. So the total area is 100 plus 1200 plus 300, which gives us 1600 square yards. Okay. All right, so here we want to find the total area of this composite shape. All right, so as I mentioned, I would break it up into, how many parts you see here. I see two shapes. We have the rectangle and then you have part of a circle, right? So I'm gonna break it up in two parts. So I label this A1 and then I'll label this A2. Okay. So A1, right? That's just base times height. That's the area of the rectangle. So base times height or length times width doesn't matter. So the base there is 10 feet and the height there is 6 feet. So we get 60 square feet, okay, for the area of the rectangle. Now for the A2, right? This is to find the area, we need to use the circle, area of a circle, right? So that would be pi r square, all right? So in this case, what is the radius here? What's the radius? 3, right? Because six feet is the diameter. 6 feet is the diameter. So we just want, half of that. And half of that is 3 feet. Half of 6, 3 feet. So we're going to have 3 square. Okay. So 3 square, 3 times 3 is 9. So that gives me 9 pi. Okay. However, this is for a full circle, right? That's a full circle. We have what? We have half of a circle. So we need to take 9 pi and then divide it by 2 because we want half of the circle. We don't want the full circle, we just want half of that. So if I did 9 pi, okay, and divide that by 2, we get 14. This is like 14.1372. Okay. So, and when I add them together, we get 60 plus this number here will give us about 74.1372. Okay. And that would be square feet. Okay. If it told us where to round, then we would round to that. Okay. But it doesn't tell us. All right, so that would be our answer here.
So we multiply.
So we just take the 60, so A1 plus A2, right? A1 was 60, and then A2 was the 14.1372. So that gives us 74.1372 square feet. Okay, so the last part here we're going to talk about is solving the formula for the given variable. So for the first one, we have C is equal to 2 pi r. We want to solve for r. The second one, we have P is equal to 2L plus 2W. We want to solve for W. The third one, we have AB equals CD plus AD. We want to solve for A. And for the last one, we have X over Y plus Z over Y equals 5. We want to solve for Z. All right, so for these ones, we need to solve for the given variable. Okay, so for the first one, we have C equals 2 pi r. We just want to solve for r. We're going to get r by itself. So what do we do there?
Do we subtract r from both sides?
So what's happening? What is the operation happening between 2 pi and r? What's the operation happening there? They're all being multiplied, right? 2 times pi times r, correct? Just like how we, you know, when they're together like this, they're being multiplied. So the opposite operation would be what? Division, isn't it? So if I want to get r by itself, we just divide by what? 2 pi, right? So I do it on one side, I must also do it on the other side. So 2 pi will cancel out, and you have C is divided by 2 pi equals R. That's it. Okay, let's look at the second one. Whoa. All right, we have P is equal to 2L plus 2W and we want to solve for W. So what's our first step here? Yeah, we want to get W alone. So what do we do? What do we do here?
Would you subtract 2L from both sides?
Perfect, exactly, right? So subtract 2L here, subtract 2L here. Exactly. So we get P minus 2L equals 2W. Okay? And then what's our last step?
And then once it's like that, would you add the 2L to both sides? Would
Now
you
remember, we
like
want to
flip
get
flop?
W by itself. We want to get W by itself. So what's the operations happening between 2 and W? They're being multiplied, right? So the opposite is just going to be divide. So divide both sides by 2. Okay? So then that's our answer right there. So W is equal to P minus 2L over 2. Okay? And don't be tempted to try to cancel out the 2. That only works if there was a 2 here. So don't do that. Okay? I see students doing that. So you leave it like that. You can only cancel it if there was another 2 here. Okay? Well, just in case the lab doesn't like it, we would divide this by 2, right? And then this by 2. And then that would give us P over 2 minus L. So just in case the lab doesn't like this answer. Okay? All right. But again, for me, I would take both, either one. All right, let's look at the next one here. This one we want to solve for A. All right. So you notice that there's an A on this side and there's an A on this side. So what's going to be our first step for this one? Yep, very good. Subtract, right? We want to subtract them. Because again, we have A here and A here. So we want to get the A's together. So let's subtract them. So I'm going to subtract AD minus AD. Now don't go saying, oh, A and A cancel. That's not true. Okay? They're two separate. So it'd be AB minus AD. These guys, though, since they're the same, you can take those out. Equals CD. Okay? All right. Now, as you look at the left side, what do you notice? Do they have anything in common? What do they have in common? The left side, what do they have in common? Exactly. They have A in common. So we can do the distributed property, the opposite, right? Normally we would multiply to them. We can do the opposite and then we can factor out. Okay? We can factor out. So I have A, I'm going to take that out, and I'll have, if I take out A, what's going to be left over on this side? If I take out A, B, good. I have B left over, okay? How about here? If I take out A, what's left over? D, good. So I have B minus D left over. Okay? Let me pause there. Okay, so now what is our last step? Again, we want to get A by itself. What's our last step? So what's happening with these two? These are being what? Multiplied, right? So what is the opposite of that? Division, right? So if these guys are being multiplied, I can divide. Okay? Exactly. So B minus D. B minus D. So this will cancel with this one. So we have A is equal to CD over B minus D. Okay? And again, don't be tempted to try to cancel the D's. Don't do that. That's not right. Just leave it alone. CD over B minus D. Okay, so this type of problem, the last one here is a rational equation. Rational just means a fancy word for fraction. Okay, so this is a rational equation, but it's just a fancy word for a fraction. You can write it as a fraction form. So when I deal with rational equations, we have the denominator. right? So I want to get rid of the denominator. So in this case, what's going to be our LCD? What's the least common denominator here we have? Y, good, right? So Y is my least common denominator. That's what I have left, right? If there was a 2 there, I would put 2Y, right? But but there's only one Y. Perfect. I'll multiply that. Okay. So that's my least common denominator. Why do I do that? Because this is a rational function or rational equation. So I want to get rid of the denominator. Okay. So I don't have to worry about it. Okay. So I'm going to, since I found my LCD, which is Y, I just multiply everything by Y. Multiply this by Y, multiply that by Y, multiply that by Y. And when I do that, then they'll cancel out. This Y will cancel with this, leaving me with the X left over. Okay. This Y will cancel with this, leaving me with Z. And then there's nothing here to cancel because there's nothing in the denominator. So I just leave it as 5 times Y. Okay. All right. And then what's our last step? I want to get Z by itself. Exactly. Subtract. Very good. So we're going to subtract X on both sides. Okay. So this will cancel. Those guys will cancel. X minus X is 0. And then we get Z is equal to 5Y minus X. And then there's our answer.